Hey there, math friends. Thank you for joining me again today. I hope you're all having a wonderful day. Today, I'm so excited because we are going to do some story problems, some word problems today. I hope you love word problems as much as I do. If you want to know why do I love word problems, well, simple answer, because my students are always asking me, why do we need to learn this? When are we going to use this? Why do I need to know this kind of math that we're teaching in school? And you know, these word problems are all excellent examples of times in the real world when we need this math. There are so many uses for all of these math concepts that we're learning. And word problems are they're a really good demonstration of how we might use those. You do have to think a little bit differently, so let's talk through some of them now, and then you can get to working on your assignment in a minute. Okay, so first of all, this is not in any of the materials I sent you, so if this is useful for you, go ahead and copy it down. These are common words that you might see in a word problem, and they're kind of like little hints what to do in those word problems. So if you see any of these words like some, plus, and, more than, increased by, that is a little hint that you're probably going to have to add in that problem. Whereas these words, difference, comparing, minus, less than, decreased by, all of those are going to tip you off that you're probably going to need to subtract. The words product, times, of, and twice are multiply words. And if you hear quotient or split evenly, then you're going to know that you're probably going to have to divide. So here's some hints. Always think about what is the problem asking for. Once you've decided what the problem is asking for, then think what information is given to you. What does it mean? And then finally, you're going to label your answer. So like if your word problem is talking about grapefruits and the answer is 6, then you want to make sure you say 6 grapefruits so that we know what you're talking about. And this is my favorite step right here. Does it make sense in the context of the problem? That one is so important. So like I said, you don't have these materials in anything that I've given you, but if this looks useful, go ahead and pause the video, grab a piece of paper, and write it down. And if you want to do some of the problems along with me, it'd be nice to have a piece of paper anyway. So you might want to grab a piece of paper and a pencil. And we're going to start with this first example. Okay. A discounted concert ticket is $14.50 less than the original price. You pay $53 for a discounted ticket. What is the original price? Okay, so step 1, like right here, what is the problem asking for? So here the problem is asking for the original price. What is the original price? Okay. Step 2, what information is given and what does it mean? Okay, so the important information from here, first of all, is that your ticket, the one that you bought, is $14.50 less than the original price. The other thing that's really important is what you actually paid. You paid $53. Okay, so let's set this up. What I'm going to do, let's read this one more time. A discounted concert ticket is $14.50 less than the original price. Okay, and we know you're looking for the original price. So let's just write this out kind of in math language a little bit. So we need the original price minus $14.50. Because it says the discounted concert ticket is $14.50 less than the original price. That's where I got this. Original price minus $14.50 equals, and now we just need to know what the discounted ticket costs, and that's what it tells us right here. It says you pay $53 for that discounted ticket, so we're going to put that there. So now kind of in math language, we know that original price minus $14.50 equals $53. Now this is kind of like an equation, except you've got this whole big word here. Wouldn't it be nice if there's just something else we could write instead of that big long word? Like maybe, well, let's just use a letter. How about an X? So instead of writing original price, we're just going to write X minus $14.50 equals 53. And now we all know that this X represents the original price. Okay, cool. Now it's just kind of like yesterday's assignment where we are solving a one-step equation. We're going to need the opposite of subtracting 1450, because what are we trying to do? We want to get this x by himself, right? We need to isolate the x, get it by itself. So we need to get rid of the 1450 by doing the opposite. If it's minus 1450, the opposite is to add 1450, and whatever you do to one side, you have to do to both sides. Okay, so those add up to be 0, so I'm just going to say they cancel out, because when you have 0, that's just the same thing as x. What I'm trying to say here is x plus 0 equals x. So those cancel out, whereas this, let's bring that down, that's going to be 6750, and I'll bring down the x over here. So x equals 6750. Okay, we're almost done. We just need to know what we're talking about here. What is the x again? Oh yeah, the x was the original price. So the original price is 6750. What's that in? That's just dollars, right? So let's give it a unit. When you're talking about money, that dollar sign works as your unit. So what is the original price? The original price is $67.50. Okay, let's go to another problem. And like I said, write these down on a separate piece of paper if you want, or you can just kind of tune in and follow along, whatever works best for you. Example 2. Your friend's final bowling score is 105. You hit down 14 more pins than your friend. What is your bowling score? Okay, so what are they asking for? They're asking, what is your bowling score? Great. What do we already know? Well, we know your friend's bowling score, and we know that we hit down 14 more pins than your friend. So let's kind of write this out in math speak. Let's just start at the beginning. Your friend's bowling score is 105. We hit down 14 more pins than that, so plus 14 equals our bowling score. And again, this is what we're asking for. This is the question. What is your bowling score? And that can always be represented by a letter, or as we might call it, a variable. So again, I'm just going to put x there instead. So 105 plus 14 equals x. Now this is an equation, but it doesn't really need much to get solved. All we need to do is add these two things, because the x is already by itself. That makes it easier. So that's pretty nice. It looks like x is going to equal 119. And if you want to, you can write it this way around. It doesn't matter to me. And now we just need units. Bowling score, I guess, I don't know, 119 points. I don't bowl, maybe you guys do. But I'm just going to assume we would call that 119 points. And we'll put it like that. Okay, awesome. Let's look at another example. Now, if you guys are cruising along and you think, oh, this is just fine, I'm ready to work on my assignment, you go ahead and do that. That's great. For those of you who want to watch another one, this is my plan. I'm going to do this example here, and then I'm going to look at some of these, one or two of these. And these are the ones that are actually from your homework. So if that's helpful to you, stay tuned. If not, go ahead and get to work. Okay, example 3. Let's read it. Says the Josh, Jack, and Jen. I don't know. I think that's a misprint. Here we go. Let's try that again. Josh, Jack, and Jen sold their dog's puppies. They split the money they made between the three of them. They each had $12 in the end. How much money did they make from selling the puppies? Okay, so what are we looking for? What's the question? The question is how much money? Now, what do we already know? Okay, we know that they split the money between the three of them. Now, if you remember, or if you paused the video and wrote it down, split, let me go back here. Split was on this other page under divide. So that's a good hint that we're going to have to divide there. Let's keep underlining information. They each had $12 in the end, so they wound up with $12. Okay. So we need to know how much money got split. So how much money, and instead of writing out the words how much money, I'm just going to write my variable. I'm going to write my x. And it got split between how many people? 3 people. And then in the end, each of them had $12. So that's how you set that up. You have a certain amount of money that got split 3 ways, and that finally equals $12. So now we have a one-step equation that we need to solve. Right now x is being divided by 3, so we need to do the opposite to get rid of that 3. We need that x by itself. So the opposite of divide by 3 is to multiply by 3. I'm going to write times 3 here and times 3 there, because what we do to one side, we have to do to the other side. And you wind up with x equals 36. So this 3 and that 3 just cancel each other out. And 12 times 3 gives you the 36, and so you have 36 for your answer. And then just to make sure you give your units, it says how much money did they make. And as we know, dollars are the units for money, so we're just going to say $36. Okay, now I'm going to move on to what is your assignment. So if you would like to take a second and pause and go print that out, you can, or you can just write this on paper. You're in charge. Hit the pause button if you want to. We're going to start with number 1. Carlos was 74 years old 4 years ago. How old is he now? Okay, let's look at the question first. We want to know how old is he now? That is our question. What we do know is that he was 74 years old 4 years ago. Now, how old is he now? Think through that for a second. Okay, so I'm going to start this way. I'm going to do his, like, how old he is now. That's going to be my x. And 4 years ago, that would be like minus 4 years, right? So x minus 4 equals this age, 74, because that's how old he was 4 years ago. And now I have a one-step equation I can solve. We want this x by itself, so we have to get rid of this guy, then minus 4. We're going to do that by adding 4, which means we got to add it to the other side also. And you're left with x equals 78. So these guys basically canceled out to 0, and 74 plus 4 gave me the 78. So now he is 78 years old now. So we'll just say 78 years old. All right. Let's do one more. Again, only keep watching if it's helpful, okay? If it's not helpful, you're free to go work on your assignment right now. Last week, Joe ran 27 miles less than Stefan. Joe ran 19 miles. How many miles did Stefan run? Okay, so what do we know? First of all, they're asking for how many miles Stefan ran. What do we know? We know that Joe ran 27 miles less than him. And we know that Joe ran 19 miles. Okay. So let's start with how many miles did Stefan run? Joe ran 27 miles less than Stefan. Okay, so let's say that how many miles Stefan ran, we're going to use an x for that because that's our question. And we know Joe ran 27 miles less than that, whatever it is. So it's x minus 27. And then, do we know how many miles Joe actually ran? Yeah, we do. That's 19. So this is Stefan's number of miles. This is the 27 less. And this is the 19 that it tells us that Joe ran. So we gotta isolate the x. We want this by itself, which means we need to get rid of the minus 27. We're gonna do that by adding 27. That will cancel. And we're gonna add 27 here also. And that will give us 9 plus 7 is 16. There we go, 46, right guys? That looks good. So it looks to me like Stefan ran 46 miles. And that is your answer. If you have any questions, let me know. Have fun with your assignment, and I'll see you again soon. Bye!